In this video, we are going to look at resolving an IPv4 hostname. So for example, if instead of putting in an actual IP address, if we put in a hostname and the IP endpoint will attempt to resolve that hostname into an IP address that we can use. Let's go into our IP endpoint constructor. If we go down here, we have if we successfully convert it, so if they supplied the actual IP address and we were doing this right here, and now we need to attempt to resolve hostname to IPv4 address. Now there's a few steps to go about doing this. We're going to call something called GetAdderInfo. The first argument is a pointer to the node name, which this is just our hostname string. The next argument is a pointer to the service name, and we're not going to use this, so we're just going to skip over that. After that, we have a pointer to our hints. Now, the way that the hints work is it's like a filter. So, for example, when we call GetAdderInfo, if we only want to get the IP addresses that are for Internet Protocol version 4, then we would specify that in our hint structure that we would pass the pointer to. The last argument is where we are going to store the result. The result will be a linked list. We're just going to take a look at the very first element in the linked list and not worry about the rest. Regarding the return value, success returns 0 and failure returns a non-zero Windows socket error code. So we'll do result equals GetAdderInfo. The first argument is going to be the hostname string, which will be just stored in IP for our constructor. The service name we decided we are not using. Next we have a pointer to our hints. So we need to create an AdderInfo struct for our hints. We are going to zero out the memory like this. And then we want to make sure that we're only getting Internet Protocol version 4 addresses back. So we'll do hints, and we will set the family to be AFINet. This will be IPv4 addresses only. For that argument, we will just pass in the address of our hints variable we just created. And last, we need a pointer to store our results. It will be of type AdderInfo. We'll just call this hostinfo. Default that to null pointer. We need to pass in the address of that pointer. If GetAdderInfo is successful, then result should be 0. The first thing we're going to put in here before we resolve any of this is anytime you call GetAdderInfo successfully, you need to free that memory with free AdderInfo on the result that you got back. So we'll pass in host info here. Now we mentioned that the result we get back is a linked list. So if we look in host info, you will see we have the AI next, which is to go to the next object if there is one in the linked list. But we're just going to look at the very first entry that we get back, because since we specified IPv4 addresses only, I would think we would only get back one address. If we didn't specify this, we might get back an IPv4 address and an IPv6 address. But since we specified it, I don't think we will. The way that we can get the address is with the AI address member. And you see that the AI address member is a sockadder pointer. Now, we don't use sockadder directly. What we use is sockadderin. We'll just call this hostadder. We will set it equal to this, but we will have to cast it. If we were using Internet Protocol version 6 and we got back an address, we would use the sockadderin6. But since we're using version 4, we are using sockadderin. Next, we want to take the IP address for this and get it in presentation format, because currently it'll be stored in network format. If we look at the host adder, we look at the sign adder member union, and then sadder, this is how we will get to the network presentation format for the 4 bytes representing that IP address. In order to get it into presentation format, we need a string to store it in. Of course, we're going to store it in our IP string member for this class. So we are going to resize this, and we're going to need a length of 16. We will cover that in just a moment about why we need 16. Then we're going to call inet into p, and this will get it from network to presentation format. So we currently have it in network and we want it in presentation. First, we will pass in the address family, which will be AFINET since we're using Internet Protocol version 4. We will pass in a pointer to the IP address represented. So we can do that with just host adder, and we can look at sign adder. Because this struct, if you remember, it really just contains a union. We could also, put in the .s, the union, and then reference the address directly, but since this address takes up the whole structure for the union, we can just pass in that structure. Next, we will pass in a pointer to where we are storing the string for the presentation format. This will be in our IP string. We're going to start copying at the very first character in the string. And then last is the size of the string, which would be 16. Now, why did we use 16? If we look at the documentation, for inet into p, for an Internet Protocol version 4 address, the buffer needs to be large enough to hold at least 16 characters. And for version 6, it needs to be large enough to hold at least 46 characters. So that's why we use 16 for this scenario. So now we have our IP string set up. Let's go ahead and set the host name. And the host name will just be whatever got passed into the constructor. For example, might have been google.com. Next, we are going to find what the bytes are that make up this IP address, just like we did up here, where we resized our bytes vector and copied the memory from the address. So we're going to store the IP as an unsigned long. We're going to get that by looking at host adder. We'll look at sign adder, the union, and then that address as an unsigned long. Then we can go to our IP. We can resize it as an unsigned long. As a size of unsigned long. Then we can do a mem copy. And we're going to copy from the IP as a long into our IP vector, starting at the first element, and the number of bytes we're copying is however big an unsigned long is, or just 4 bytes. Next, we need to make sure that we set our IP version. If we successfully resolve this, given that we use the AFINET address family, this will be Internet Protocol version 4. After we clean up our memory, we're just going to return. And then later on in the series, when we implement Internet Protocol version 6, we will have additional logic down here to try to resolve the Internet Protocol version 6 address or host name. Let's go ahead and give this a test. We go into our source CPP. Now we're passing in google.com. The port is still not being used. We're just passing in anything here. So let's give this. So when we run this, we will get, alright, google.com, we get this IP64, whatever. And IP, whoa! What? Oops. And I just realized this is backwards for the mem copy. We are copying from the IP into our bytes. I had the source and destination mixed up there. So now if we try to resolve google.com, we should get an IP address for them. So let's test this. Alright, we see this IP, we got 64.233.177.147. And if we look this up, you'll see that this is a Google IP address. In the next video, we will look at how to bind a socket.